A mini launcher is set up on a ledge that's 1.2 meters above the floor. Launcher shoots a ball at a 30-degree angle, and the launcher has the ball moving 7 meters per second. We want to calculate the range of the ball in this case. Now, key here is it's 1.2 meters above the floor, so this is not coming back to the same level like our first angled projectile problems, and so calculating delta x will require a little bit of different thinking. And here are the calculation of the horizontal and vertical velocities upon launch, initial velocities. 6.06 meters per second horizontal, 3.5 meters per second vertical. And now we'll fill in the table values. In the table here, if it's blank, we don't know what it is. It's a quick solution if we know everything about horizontal. If we want to know how far it goes, we multiply horizontal velocity by time. We do know the horizontal velocity, which is unchanging. We do not know the time, so can't use that right now. So looking at the y motion, we have three things that we know. So we'll look for an equation that has those three things plus time, which we want to know. That would be this equation right here. And if we plug in what we know, we end up with this, which really is a quadratic. If we bring this 1.2 over to this side here, we have 0 equals 3.5t plus, really that's a minus 4.9 t squared plus 1.2. And instead of x, we have t here. This is like a quadratic, where quadratic being 0 equals ax squared plus bx plus c. Solve for x. Well, we have t instead of x. This would be our a. This would be our b, and this would be our c. And if you use the quadratic formula, you can solve for t. If you want to do that, you can. There's another way. We'll use this kinematic equation here to solve for v, and then once we know v, we can find t. That'll be a little bit easier. And solving for v here with the square root and everything, we get v equals 5.98 meters per second. And now we can use another kinematic equation to solve for t. And this equation is an easy one to use, and we know everything except for t. Solve for t. So notice here Vy is minus because when it comes down here and hits its vertical component, it's going to be in the downward direction or negative. So that's a negative value there. And that's Vy. Subtract from it the starting velocity, divide by A, and we get time is 0.97 seconds. Now time, that's the time in the air, and now we can go to the simple constant velocity formula for horizontal motion, and its horizontal displacement will equal its horizontal velocity times the time that it is in the air for the trajectory shown, and delta x equals 5.9 meters. That's how far it will travel horizontally.